In this class, we're going to consider how you integrate the trig functions sine and cosine. So like all the integral rules, this works in reverse from its equivalent in differentiation. So as a quick reminder, in differentiation, if you differentiate sine ax, you get a cos ax. If you differentiate cos ax, you get minus a sine ax. So those are the derivative rules. When we look at the integral rules, they've somehow got to reflect that in reverse, like the opposite of that. The important point with these, though, was the fact that this a value here, which in reality is going to be a number value, like these guys I've got here, that a value there doesn't just go there because there's an a there. It goes there because a is a derivative of ax. So when we come to look at these guys, we're going to have to consider that fact in the same way that we should really consider it for the derivative rules. It's very easy if you see, for example, a 4x in here, to just say, oh yeah, well, it will just be a 4 there. So that is generally going to be true if this is in the form ax. But if this becomes more complicated, then the resulting derivative would be more complicated. And that's going to be the same when we come to consider the integrals. But certainly these kind of basic rules would be your starting point, and we would just later on consider some of the more difficult cases. So when we come to integrate, then we just have to reflect the opposite of these rules. So one thing about that would be that if you integrate, for example, sine ax, instead of getting positive cos, you get negative cos, and instead of having the derivative of this term in front, it's going to be the 1 over the reciprocal of the derivative. So you're going to end up with minus 1 over a cos ax. And for the cos rule, in differentiation it becomes a negative, in integration it will stay positive, so it's going to be 1 over a, so 1 over the derivative of this term times sine ax. So that's generally how you'll see these rules presented on a formula sheet or in a textbook. Okay, so let's take these and apply them over here. So most of these scenarios are fairly straightforward. We might look at a couple more examples as well. So just taking this guy first of all. So cosine integrates to positive sine. The derivative of 3x is 3, so it's going to be 1 over 3 positive sine 3x. Because we're integrating, we need to remember to put our plus c on the end, and just whatever's in the bracket here stays there. That never changes, okay? And that's the same with differentiation. So for that guy, we're done. This guy also fairly similar format to what we had over here. So sine integrates to negative cos. So the 4x is a derivative of 4, so it's going to be minus 1 over 4, 1 over the derivative cos 4x plus the constant of integration. So again, pretty straightforward. This guy, we've got a coefficient here, number in front. Nothing really much to do with that, other than just sort of leave it there. Sine integrates to minus cos. The 6 is going to be on the bottom of the fraction, so this time we'll get minus. We could write it as 5 times 1 over 6, but we may as well just write it as 5 over 6 cos 6x plus the c value on the end again. And then finally, checking out this guy, cosine integrates to positive sine. When you start this topic, by the way, having already done these trig function types in differentiation, it's fairly likely you'll get your signs muddled, so you'll make a plus into a minus and a minus into a plus. Everyone does that at first, that's totally cool. You can expect almost to make that mistake. So you look at this and you've probably already seen a bunch of cosine derivatives, so you're thinking positive sine, but for this one it's, you're thinking negative sine. See, exactly right, I'm getting them wrong as well. So you're thinking from differentiation, negative sine, you've got that associated in your mind. For integrals, it's positive sine, so you've got to keep that straight. It's not always easy. So this one, you're going to get 3 over 3, positive sine, apparently, 3x plus c. That would simplify just down to 1, so it ends up just being sine 3x plus the constant of integration. So not too bad actually, those rules. You can see slightly more difficult scenarios. So let's say the part in the bracket is a more complex function. So let's say you had something like 3 sine 2x minus 5. So it's kind of this almost polynomial type term in there. Just go about it in the same way. So sine integrates to negative cosine. The 3 would stay in front. We're just dividing by the derivative. So the derivative here was 3. This is an extra term, but it's still just got a derivative from the power rule, which would be 2. So we're going to end up with minus 3 over 2 cos 2x minus 5. So the bit in the bracket, again, just staying the same, and then putting our plus c on the end there. So this part can change, and if that part does change, you'll need to think more carefully about the derivative. But in general, the rule is still going to be applied in the same way. Let's look at one more. So let's say we've got the integral of cosine x squared. So it's fairly common to see functions kind of like this, where you've got a sine or a cos and then some kind of powered x term inside. So what we need to think about in this case is the derivative of this guy here. So the derivative of x squared is 2x. So we're going to do 1 over 2x. Cosine integrates to positive sine. So sine, leave the bracket the same, and then just put your plus c on the end. So as they get more complicated, you might need to consider more carefully the rules and the derivatives in particular, but the overall scheme kind of remains the same. Just to go back to these, both the derivatives and the integrals, the reason, by the way, why we put this derivative of ax in front, and the reason why we do 1 over here, is because we're applying the chain rule. So if you've seen the chain rule for derivatives and integrals, you'll know it involves composite functions, but that's what this is here, because you've got, for all of these in fact, you've got basically a function, ax, inside another function, cosine. You've got a function, ax, inside another function, sine. So that means that this guy here is a composite, and in composite functions, we're always considering the overall derivative or integral and the inside part as well. So that's basically where this rule comes from. It's really an example of the chain rule for composite functions. So not the most difficult technique for integration, this one. Run through a few examples of the basic types. Once you've got those, which you'll probably get down fairly quickly, try and scope out a few more elaborate examples, just so that when you see them in an exam or a test or something, you don't get thrown off. So yeah, check out a few practice questions on this topic.